Hello everyone and welcome to another QualiTest webinar. It gives me great pleasure to have our partner Vericode guest presenting with us today. My name is Sarah Taylor and I'm your host. Before we start, please take a moment to check your audio visual settings while I run through a few items about how you can take part in today's event. Aaron, could you go to the next slide please? Today's webinar is being recorded and you will receive a copy of this recording within a few days of transmission. This session will last approximately 1 hour and includes a Q&A session. If you have any questions, you can submit them the usual way by typing them into the questions pane of the control panel. The control panel is situated on the right-hand side of your screen. We will collect your questions and address them during the Q&A session at the end of the presentation. It now gives me great pleasure to welcome Aaron Schneider from QualiTest and a very warm welcome to Tom Smith from Vericode. I'll now hand over to the presenters who will tell you a bit more about themselves. So Aaron and Tom, over to you.
Thanks, Sarah. It's really a pleasure to be here. I'll start off by introducing myself. My name is Aaron Schneider. I'm a Senior Solutions Architect at QualiTest, and I work as part of our Solution Engineering Cloud to be able to work with all of our different customers, both new and existing, to sort of identify the best set of tools and methodologies and processes to best answer the quality assurance needs of our customers. Tom, over to you.
Thanks, Aaron. Yeah, hi everyone. I'm Tom Smith, Solution Architect at Vericode. So I'm predominantly in a pre-sales capacity in the role that I am at Vericode, but I also do a lot of post-sales, so helping prospects understand the value of the technology set, but also the underpinning services that we offer, and also helping roll out of the solutions with our program managers. So yeah, really happy to be here today and looking forward to cracking on with the presentation.
Thanks, Tom. It really is a pleasure to have you with us, and QualiTest and Vericode are quite close partners, and it's always a pleasure to work with you and your team.
Likewise.
So let's jump into a quick brief overview about QualiTest. So we are the world's leading AI-powered quality engineering company. So we work, cross-vector, cross-sector to be able to ultimately provide state-of-the-art technologies in terms of answering that quality assurance need, no matter what the system or technology is. We have an incredible AI process that helps us really use cutting-edge technology to build the best possible solution that we can. And with me today is Tom, who is going to be giving an overview of what we'll actually be discussing in today's webinar. So I'm going to pass over to him to give the introduction, and then we'll get into the meat of it.
Fantastic. Thanks, Aaron. So the title of today's session was Debunking the Myth of the AppSec Silver Bullet. And it's really about this common misconception that we see in the industry that maybe one testing technique or approach is all you need for an effective AppSec program. But a lot of the times, that's certainly not the case, because in reality, it can be quite a complex area, right? You need a good blend of different tools, but also there's a lot around culture and, looking to drive security approaches throughout the business, not just, siloed teams. So today's session is really going to be focused on an overview of the different scanning types that are available, some of the benefits of those and some of the challenges that also come with those testing types. A little bit around, it's not just about tooling, it's also about the wider application security approach, how we can then integrate and some of the best practices around integration and automation of the testing, and we'll give you some tips on sort of some of the first steps that you can go through from day one, really, as you're just starting off on your AppSec journey, 60 days, 90 days to give you a good starting point. And then we'll have a quick Q&A and discussion at the end. So I always think it's nice to start off with an analogy, just to kind of cement that understanding. And I think a really good analogy for application security testing is the human health, because like AppSec, the human health is not just one type of testing or one type of test that's going to tell you whether you're healthy or not. Really, it's a multiple set of tests that you can utilize to determine whether your body and your mind is actually healthy. So for example, X-ray a point-in-time scan of your body, the internal workings of your body to identify any faults or breaks. Reflex testing is a bit like your run time, so we can poke and prod the body to see what sort of response that we're getting and that it's within tolerance. Dental exam, so yeah, looking at maintenance of your teeth, for example, maintenance of the body. Stress test, this is very good for putting the body through its paces, really, making sure that it's kind of behaving the way it should when it's under stress. And then psychoanalysis, of course, the logic of the mind and the logic of the way that you control your body is key, making sure we haven't got any negative behaviors in there and negative logic. So if you think of application security and how that ties in with some of the human testing that I talked about, static analysis is very much like your X-ray. So we're looking at the source code and we're determining whether that source code's got any defects in it right from the offset. Reflex testing a bit like dynamic analysis in the sense that we're taking the runtime of the application and we're sending requests to it and we're seeing what we get back and whether that's actually within the tolerance that we expect. Software composition analysis, this is a little bit like if you think of your teeth having fillings or some type of dentist work to maintain, so it's like a third-party component that you need to look after and maintain to ensure its integrity. Interactive application security testing is very much like stress testing, really, so we're using a set of tests to exercise the application and then seeing how it responds and behaves. And then pen testing is a bit like psychoanalysis, we're looking at the logic of the application, making sure it's behaving the way it should do, and that there are no defects and issues. So let's dig a little bit more into each of the testing types and talk about some of the benefits and some of the challenges. So first of all, static analysis, the way that works is that we take either the source code or the binary of the application, and then we basically use control flow and data flow analysis. So we create a model of the application, and then we'll trace the data pass through the application from the source to the sink, and then we can identify if there's any vulnerabilities or flaws, in that application. Because of the nature of the way it works, it's good for automation, so it's great for implementation into sort of IDEs, into pipelines. So generally, if the application's a reasonable size, we should get quite quick scan times as well for things like microservices or APIs. It's quite a mature technology, so we can scan web apps, mobile, desktop APIs. We've got a broad set of languages that are supported as well with SAST. Some of the cautions or things to be aware of is that we're not looking at business logic with static analysis, and also it's not covering any third-party components. So if you're using open source components in your application, static analysis isn't necessarily going to pick that up. Dynamic analysis is really focused on runtime. So we would typically connect to the front end of the application, the web application. We would use the URL, we'd crawl the site looking for any forms or search fields where we could try and manipulate and use injection techniques, that type of thing. So probably one of the major benefits of Dynamic is that it's pretty straightforward to set up and kick off. You don't need involvement from the developers necessarily. If it's publicly accessible, you just need a URL, maybe a login. It's independent of the programming language due to the nature of the way that we're interfacing with it. We just need that web front end. Some things to be aware of, though, because of the testing type, it takes a little while to run, right? So it's not as quick as something like static. So you really probably want to run it on a schedule, maybe on an overnight schedule, because it's going to take a bit longer. Not always so suitable for automation in the pipeline, for example. SCA, so this is focused on third-party components. So if you're, well, like most applications now are using open source libraries, so often can be up to sort of 80–90% of open source software. Of course, it's important to understand whether those open source libraries contain vulnerabilities, whether there's any license risk inherent in those as well. And the way that our SA typically works is it works with fingerprints. So the libraries are pre-scanned and the vulnerabilities have been identified, and then we create a fingerprint of that library and we hold it in a database. So when we scan your application, we can just look at what libraries are there, we check the fingerprint of that library. If it matches in our database, we can guarantee that that's the same library. And the reason I've explained that is because it's a very quick process, right? You should see an SCA scan in under, a minute or two, right? So it's very fast, which means it's very good for automation, very good for integrating into the SDLC. ID scans, again, is a good use case for that. Cautions are, of course, it's only third party. It's not looking at any of your first party code, and also it's not looking at any of the business logic in the application. IAST, which is short for Interactive Application Security Testing, is more recent technology, I suppose you could say. And the way it works is it augments the application, so it's like an agent that runs in the application at runtime. But it does require the application to be exercised, a bit like stress testing, right? So you need some mature QA type scripts that's going to run through the application, generate traffic, so we can then monitor that and identify vulnerabilities. Because it's real traffic, we find that it has a high accuracy rate as well. So low false positives, which means that the results are generally more meaningful. It's very much a developer-focused tool as well, so it's good for automation in the IDE or in the pipeline, and it's generally pretty fast as well. One thing to be aware of though is that because it's a newer technology, it doesn't quite have the same coverage on language, and also in terms of the types of flaws that it covers, a little bit more limited, and it's typically a bit more expensive as well. And then lastly, penetration testing. So this is really a human-initiated form of testing, ethical hacking effectively. So it has it's often required for compliance. And when we talk to organizations, if they're not doing anything around AppSec, they are generally at least doing manual pen tests right before they go into, release into production. So it's generally very late in the cycle. Some of the strengths around that are a manual pen tester can find vulnerabilities that you can't really find through automated testing. So there's definitely a place for it, and it is very important to also do manual pen testing. But of course, it's expensive. It's late in the cycle, so there are some weaknesses around causing friction with development teams, having to block them and then going right back to the beginning to fix these issues. So I think this slide's nice because we take all of the different testing types and we're putting them together on this table that showing, the capabilities and where the strengths and weaknesses are in each testing type. And if you think, one area of interest here is manual pen testing on the right-hand side. You can see that it pretty much covers most capabilities. So you could think, well, that's a strong candidate. Maybe I could just stick with manual pen testing. But as I mentioned in the previous slide, the limitation to manual pen testing is that you can't automate it because it's a human that's actually carrying out that testing. And also it's not very scalable, right? Because it's human, you can't automate it. And also it takes days to weeks to run manual pen tests, and it also is very expensive. So of course, there's a place for it, but it's important to use other testing techniques such as static analysis and software composition analysis that are much more aligned to automation, much more scalable, and also those technologies are generally going to pick up some of the low-hanging fruit, the easier issues that should be picked up by automation, right? So then when it comes to manual pen testing, you're just covering off those last few bits, maybe looking at the more business logic focused flaws, and then you're not having to kind of go back all the time to fix issues that really should have been picked up in those early phases. It's worth passing over to Aaron actually. Have you got anything to add in terms of or manual pen testing, what you've seen in the industry with your customers?
Yeah, 100%. I think just in general, companies really overemphasize manual penetration testing. They really look at it as like, yeah, we're doing pen testing, we don't need to worry, we've got our bases covered, we can abstract away all of our security issues and just say, tick, we're doing our pen testing. But as you've just shown in this brilliant overview of all the different types of testing you can do, it gives you this false sense of security, literally, that you think, oh, pen testing done, but really it's so late at the cycle that if you do find any issues, you have to go way back into the development to solve them, and it's ultimately a barrier to releasing. And if you use all these other different testing types and you take a more holistic approach to combining all these different toolings, that you can find these issues earlier, and you can just use penetration testing almost as that like last little check where you're just looking for the biggest problems, making sure that you're actually covered and not relying on it to solve all of your security issues.
Brilliant. Thanks, Aaron. So we've been talking about the technologies and some of the benefits and challenges of those, but I think it's important to highlight in this slide that building out secure applications is still hard. Even when you've got the technologies and you've got a methodology in terms of how you deploy them, we're still typically seeing over time, there is a trend in the right direction, but still organizations are struggling to reduce the number of flaws in their applications, for example. And some of this data has been pulled out of our State of Software Security report. So this is a report Veracode generate every year. Because we're a SaaS solution, we get visibility of all our customer scans. We're able to create some trend data that's really interesting to look at. And I think really what the trend we're seeing here is that there are improvements, but it's kind of slowly moving in the right direction. I think there's a few reasons for that. Firstly, we're seeing a lot of developers coming out of university haven't necessarily had the level of secure application training that you might expect. So sometimes issues are still being introduced early in those development phases. Also, integrations can be a little bit challenging, and I'll go into a little bit more detail on the next slide. Testing's often run a little bit too late in the cycle. So as I mentioned earlier, issues are being picked up too late and then it's having to be fed back, and it can be time consuming and costly. And also enabling developers, giving them the right training and also the right tooling really to make it a bit more seamless for them rather than almost being a bit of a blocker. And I mean, Aaron, is there anything you think I missed there perhaps that's worth mentioning?
I don't think you've missed anything, but every time I see this, it just makes me go crazy, because if you look in the news today, literally every day there's a new article, a new breaking news release where there's been some company that's been attacked. In fact, this week, just before July 4th, we saw another huge attack where hundreds of companies had their information and data held hostage. And, these are problems that are facing companies today. A few years ago, we thought, wow, it's never going to be me. It's going to be those big companies. I don't need to worry. And we've seen the motivation change. It used to be just white hat hacking where people were doing it for the good of the world and trying to expose big companies doing the wrong thing. Now, people are hacking because there's some money in it. And they're hacking all day long as a business venture. And companies really need to internalize that so they can start thinking, damn, I am exposed. These are my vulnerabilities. I need to accelerate my journey towards proper, authentic application security today, because every day that I don't, I'm leaving myself open, and it is a huge risk. I'm only going to see the ability for hackers to penetrate, get even stronger and more innovative, and we need to continue, at least get us above that baseline so that we can continue to innovate in our own internal application security to combat those threats. Back to you, Tom.
I mentioned earlier integrations and some of the challenges with integrations, and some of the customers that I've worked with and through some of our research, we found that especially in large organizations, it becomes quite a challenge to fully integrate into these development teams and automate some of the testing types I mentioned earlier, such as static, SCA, dynamic, that type of thing. As we move forward with development and it becomes more critical to organizations, they're focusing a lot more, of course, on faster release, faster deployment. So therefore that puts challenges towards the security team and how they manage security testing and how they feed that back to the development team. So of course, if we're releasing every day or multiple times a day, security needs to be embedded into that process. It can't be an afterthought, and also it can't really slow that process down. So of course that's been a big challenge. We've seen testing a little bit too late typically in that process, so around sort of the testing and production, as you can see from the image on the right hand side here, we need it to be a little bit more towards the design and development stages. Also static analysis, for example, could be a little bit slow traditionally if we're working with monolith applications, and developers obviously have to wait for scans to complete. They don't want it to be automated into the pipeline because it's just too cumbersome for them. So of course, good tooling that developers can take on board, utilize without having to learn a new interface, so IDE integrations and also integrations into pipeline is key. But also enabling them, right? So being able to help them fix the issues, because finding it's fairly straightforward. It's the fixing it that's the hard bit, especially if you're testing old applications that have got a lot of security debt. If you go to a development team and say, look, I found 150 issues, you just need to go away and fix them all. You need to be realistic. So you need to define what's important to focus on in the first instance, and then enable developers to actually fix them, right? So education and sort of culture, and I think Aaron will touch on a little bit more on that stuff going forward.
Yeah, I think that's a great point to take us into the next section. And Tom, that was really a fantastic overview of all of these systematic types of tests that we can do. And returning to that analogy, we looked at how we can take these different test types that we do for humans and how we can relate that over to security scans. But there's another part of the puzzle that I think we can add to our analogy. We go to a doctor to get ourselves checked and find the problems, but actually living a healthy lifestyle starts at home. So I've added to the picture here dieting and exercise. Dieting, you regulate what you eat, make sure you're eating healthy foods, that you're having a balanced diet to keep your body working well, so you can actually don't have to rely on the doctor as much. And the same goes for exercise. We want to generally maintain our bodies by keeping them active, by doing the work that keeps everything active and involved in terms of our daily life, and making sure that we are living healthy. So we can actually add two different names to these sections. So we can talk about the top half of our analogy in terms of analyzing our health, finding the issues, and the bottom half in terms of sustaining our health, living a healthy life. So if we go back to the security application world, we can take that back into our analogy, and at the bottom we can relate dieting into a security mindset. So what do I mean here? I mean, generally instilling a culture where security is important in terms of your organization, and exercise as security assurance, which is democratizing security testing and making sure that security is considered every part of the testing lifecycle. So let's delve a little bit deeper into each of these. And we'll start with the security mindset. So the security mindset is really making sure that everybody is in on the game, where everybody is not just getting themselves tested, but is making sure they're eating a balanced security diet, where they're considering security in every single thing that they do, whether it's part of development or just in terms of being an employee at a company, making sure that you're conscious of what is happening around you, how you're treating your information technology, and also building security as a fundamental part of your application design. So when I come to build my application, I want to make sure that I have security requirements formalized. They're not just some esoteric idea, we have to have a secure application, a secure system. What does it mean to have a secure system? Write that down so that you can actually, as we'll get into the next step, test on those as well. So you want to be able to build a culture where everyone's thinking about it, where they're proactive to security threats rather than reactive. And by doing this, you can actually avoid issues becoming ever relevant. Now, this is great, but it has some risks. It's not 100% foolproof because humans are fallible. No matter how much they care, they make mistakes. And instilling that culture shift, making it happen is difficult. And at the end of the day, it doesn't actually change the code. So that's why we also have to rely on that general upkeep, where we're talking about security assurance, which is where we are including security as part of the general QA cycle, using either manual or automated testing. Now, historically, to do security testing, things like pen testing, you needed security experts. But the goal of this is to use that mindset to democratize security to just the average QA team. So that QA teams should just, as usual, part of their regression testing, be able to also test on those security requirements that you have now formalized and making sure that they are verified. This is great because you're using your existing QA resources who are experts in testing. So they know how to make sure that a test is working and a test is actually functioning and delivering on those requirements, and you're also bringing testing way earlier. Instead of just using the scans, you're now leveraging your testing lifecycle as part of that security approach. Now, again, it's not 100% foolproof. Yeah, if you look at any QA cycle, you never get to 100% coverage. It's just an impossible goal to ever realize. And so the same is true of any testing that's done as part of QA. And it takes time. Now, the reason why I've highlighted these is because the first half of this webinar, Tom brought us through some incredible different types of scans that we can do and all of the different strengths and weaknesses. However, we also have to keep in mind that tooling isn't the answer. Tooling is incredibly helpful, but if we rely too much on tooling, it actually offloads responsibility from the people who are actually writing, designing, and testing the code. And if you just say tools, 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 tools only, then people are going to say, I don't need to worry about it. They're going to become lax. They're going to make mistakes. And the developers are going to lose ownership of security. And it actually might lead to more issues because they're no longer taking that proactive response and just looking at the outcome of those reports. Now, again, it's important to reinforce that your risks and your attack vectors as a company don't only come from the code. And being able to build a culture where everyone's considering security in everything that they do can help you better protect yourself. And like Tom said, tooling just finds the problems. It doesn't fix it. And to do so, you have to make sure that your developers are enabled with the know-how and understanding of those security issues. So when they get a report that says, hang on, you've got a problem, there's something wrong here, they can actually fix it instead of just looking at that like, oh no, what do I do now? Tom, do you have anything to add there?
Yeah, I think with this slide, it kind of brings to mind when you talk about culture, which is really focused around, it's not really the tooling, it's about trying to drive responsibility across the business for security and enabling the teams to do that, right? So rather than relying on security to be the ones that are, signing stuff off and saying, yeah, that's good to go. In reality, we pass some of that responsibility or a lot of that responsibility to the development teams, right? So they have a security champion, they understand what the security requirements are that have been defined, and really they're enabled to make decisions on fixing issues, right? So they've been trained and they have regular training to help them with the remediation and fixing side. So I think that's an interesting point to add there.
100%. Couldn't agree more. So let's pivot a little bit. Now that we have spoken about, the different parts of our analogy, how we test for security and how we can sort of upkeep that by having that security mindset and that security assurance, let's talk about how we can make this happen and put it all together. So I'm going to pass back to Tom to walk us through this next section.
Yeah, I mean, this slide is really showing, okay, you've got all the different components and, we've talked about the benefits, but how do we bring those together and a few tips and tricks around, best practice? So I think when we talk about integrations of tooling into the SDLC, you're generally, you're having like a trade-off really between speed and scope, and where you test is obviously going to define the scope and then ultimately the speed of how quickly you're going to get the results. So if you think of pre-commit scans, basically the developer, when they're working on the code, giving them the ability to test as they go along, getting early visibility, that's going to be quick, but the coverage is going to be limited. And then as we go to like building the application, which gives us, the full scope of the app, it's going to take longer to scan, but you're going to get more coverage, which is important, right through to actually deployment of scans where we're introducing things like dynamic testing, pen testing. The scope then is increasing, but of course, the time is increasing significantly for doing like manual pen test. So a little bit of thought around getting the coverage of testing types, but selecting the right points in time to be implementing those. And if we dig into that a little bit more, there's a concept here where we say my code on the left, our code in the middle, and then production code on the right. If you think of my code, is basically the developer's got a copy of the code. Locally, they're working on maybe a feature. They're looking for some feedback from security testing very early on in that cycle. So static analysis is a good one to be using. SCA, even IaaS can be run from locally within the developer's workstation to get fast feedback, which means they can actually correct stuff as they go along. But obviously the scope is going to be limited to maybe those individual source files that they're scanning. So it's also important as we go to our code, where we're basically committing code to the repository. We're doing a full build of the application. That's a great point to start doing security testing alongside your unit testing and integration testing. So a full static scan, again, IaaS is a good use case there to be looking for those vulnerabilities. And then as we go to release, pushing into production, this is a good place for maybe like on a pull request as you're looking to merge into master. We can be doing more significant scanning, dynamic, pen test probably a little bit later in that cycle. But really the most important part here is having full reporting. So being able to report across all of the different technologies in a holistic view and a holistic report that says, yeah, we tick the box, security team or whoever it is that signs that off, is happy and we're good to go and release into production.
Awesome. Let's talk a bit about how you build a security assurance pipeline, how you actually say, okay, well, I want to now, as part of my routine testing, also test for security issues. So to do so, it's a good place to start with, well, how do we generally test and how does that test design process work? Well, it starts from requirement analysis. That's where we look at our application, we look at our tools, at our functions, and we figure out, well, what are the requirements? What do we need to test? And then we build a test that will test those requirements, and then we run that test either manually, by hand, or with the assistance of tooling to be able to run that in an automated fashion. So let's move that over to security. What do you do? The exact same thing. And this is why we call it democratizing security, because it's the same process. It requires looking and finding those issues that can possibly arise, defining those into actual requirements, into user stories and epics, and building tests that check those, and then just running those. And anyone can run those tests because you want to make sure that that knowledge is no longer just locked away in the experts, but everybody understands what's at stake. Everyone understands why it needs to happen. And you can make security testing just any other non-functional testing. Companies these days are testing for accessibility. Performance is classically important. And now security is. And that should be part of our general non-functional requirements. When we look at a security culture, though, it's a good thing to keep in mind what it should look like at the end. Because you say security is important, everyone needs to buy in. Well, what does it look like when everyone has bought in? Well, it starts with everyone owning security. Everyone knows that it's important, and everyone understands what their role is in the picture. So if you look at the designers who are thinking about how the application should be built and what the new features on the horizon are, they need to make sure that they have security in mind when they build that product. Developers who are actually building the code that is going to implement that vision need to ensure that they're considering security risks as part of every single line of code that they are writing. Not just writing it, but thinking, oh, hang on, this button, could it pose a risk? Let me think about that and see if I can write it in a better way. Testers, of course, need to ensure that security is part of their toolset, as they are testing their application or building the automation scripts. They are also incorporating security requirements as part of it. And of course, tools and scans help us reinforce the confidence and make sure that we can find issues and solve them. It is an educational process. It means that you need to make sure that people don't just get told, do this, do this, do this, but understand why. That they're taking on a journey to understand what are the different sorts of security threats, what are the risk types, what are the different vectors, what different types of hacks there are, how they can be attacked, and what are the possible breaches. People inside the company need to know what those are so they can be wary of them, so they can believe in them, and so they can equally be worried about them and equally make sure that they are lowering the exposure that the company has. And it also makes sure that everyone understands that they're on the front line, that everyone is in some ways a risk and a custodian of that security. Because if one person slips up, well, a malicious actor only needs one little foot in the door, because then they can break it wide open. So everyone needs to keep that on their mind and make sure that security isn't something extra, but is something core to what they are doing, how they are developing, and how they are acting as employees at a company. Tom, do you want to add anything here?
No, I think I'm good. I think I mentioned earlier about the enablement side, and I'd probably just reiterate that topic. So I think, I'm happy. Thank you.
100%. So, we've spoken about now how an ideal situation looks and how it's implemented and all the different testing types and where they fit in and how a security mindset can actually be instilled. Let's actually stop talking about it as this, wow, this is what we want to do, and let's make it happen. How are we actually going to do it? So we have built here a few guidelines to help you actually start on that journey and make it happen. And I'm going to pass over to Tom to kick off day one.
So I think the first steps really is to get a feel for, what's actually happening in your development teams as it stands right now. Because if the organization hasn't thought about some of these things, then, some of the development teams may have already taken steps using open source tools or certain techniques to be kind of ticking some level of the box, right? And so it's important to get an understanding of what they're doing at the moment and how that aligns to kind of where we want to go as an overall organization. It's important to look at your applications. So what's the portfolio of applications? What do they consist of? What teams do they align to? And also like what criticality level they sit at. So it could be sort of elements like, whether it's public facing, internal, whether it's processing PII, whether it's processing payment details, will obviously then dictate, what the framework needs to be for that particular criticality of app. So, what does good look like for a high critical app? This is an important app for the business. We need to make sure we're sort of taking the highest level of testing and security in mind. So that's an important part to get that aligned. Involving developers as early as possible is key as well, right? I see this time and time again, is that often a security team want to take on some tooling, or an AppSec program, but they don't converse with the development teams properly, and they kind of bring them in too late in the cycle. And the tooling really needs to align to the developers. The developers need to be on board with it, and then they need to have trust and belief in the technologies that are being used. So, of course, something that's going to integrate easily for them, it's not going to be too much of a blocker for them, and involving them very early on is key at that point.
100%. It's really important on day one to start making sure that you get the buy-in from all the important stakeholders and that you really start that conversation, that everybody understands the process that's starting, where they fit into that process, and how they can make sure it's a successful process. It involves making sure that you actually start formalizing the security requirements, take it down from, security is important, to this is how we make sure that our security is considered. And you can start to then build out a process to start making designing and designing tests that check those requirements. When we look at day one, what the real object here is to make sure that you're starting to map it out. On the right here, we have a maze, a hedge maze, and that's because it serves a dual purpose here. Because on one hand, how to start, it can feel like a maze, navigating your way blindly, and hopefully we're trying to give you some pointers on how to start. But also because the best way to start is by starting to map that out, starting to map your way through the maze, making sure that you actually have a process like this where you know what's your first steps, what's your next steps, so that you can ultimately map out all your different technologies and systems and be able to incorporate proper application security testing into them. Tom?
Yeah, so 90 days in. So 90 days in, if you think about at this point, we really should be looking at automating, right? So the tooling that we talked about should be aligned, and developers should almost even have a self-service option. They don't have to come to the security team to start integrating and scanning their code. They have the artifacts, they have the information that allows them to go and help themselves, right? Get integrated, get scanning, and at that point, obviously, they have an understanding of what needs to be, what standards need to be met to actually release into production, because it's been well communicated before they even start scanning. So that's obviously an important part 90 days in. KPIs, again, surfacing the right information in dashboards is very important. And it's not just from a security standpoint, but also development teams as well, because different teams want to see different data. And if they get visibility of that data, it's really going to help them. So that's definitely a key part, really surfacing that information for them. And I think I'll pass over to you at that point, Aaron. Carry on.
Yeah, I think your point here about KPIs is critically important, because ultimately, to make sure that 90 days in, everything's going well and you're going in the right direction, necessitates understanding where you are and where you currently stand so that you can start improving those. One of those is understanding, well, what is our coverage currently in terms of our quality assurance? Are we making sure that most of our requirements are covered? And being able to actually write that down as a number so that we can actually understand our goal. Again, going back to that automation point, when I'm talking about incorporating the testing team in the security testing, being able to move over automation in general is important in testing, but it's incredibly important also in security, making sure that we can lower that time to actually execute our tests. And in general, you want to have like a touchstone to see, well, are people talking about security? How's our culture going? Are people getting sick of it? Do we need to maybe shift the way that we're talking about it? And are in general people thinking about it? When you look really into the future and you go to the 6 months and beyond, you want to generally be striving to get those KPIs lower and lower and lower. And you want to make sure that you are continually improving. At Quality Test, we always talk about continuous improvement and making sure that you come in, you reassess, you reanalyze, you make sure that the process that you're going under is still working, it fits your requirements, is actually answering your needs, and that if it is, well, how do we make it better? How can we lower that bar so that we can make sure that security is even more critically dealt with? And focusing on KPIs like mean time to resolution. How long does it take for us to actually address an issue that is raised? And making sure that we're not just solving flaws, but introducing fewer flaws. And in general, taking this always constantly looking back at where we are to make sure that we can make any changes that we need to make sure that this process is working. I think that brings us to the end of the content. And Tom, thanks so much for really guiding us through that as well. But before we end off, we wanted to open up to any questions from the audience. So Sarah, do we have any questions that we can tackle?
Yes, there's a couple have come in now. So first one, as a company just starting this journey, do you have any tips to be able to hit the ground running?
Wow, okay. So, apart from everything that we've just gone over, I think it's important to remember that mistakes are made. As a company, as one team, it's impossible to get it right 100% of the time. And in fact, as starting on this as a new team, it's even harder. And sometimes it's actually, really important to bring in some external help. And, today this has been hosted by me and Tom, who's from Vericode, and they have an incredible suite of tools and specialists that can help implement those tools. And us to a Quality Test, we've helped go through this process a number of times with different companies, and we can provide that helping arm to give you that sort of kickoff to make sure that you can sort of accelerate that process and make sure that it is a successful one instead of walking through it blind. Tom, anything to add there?
Yeah, I think it kind of ties back to something we said earlier, or Aaron, you said it, in terms of getting the right people involved early enough, the stakeholders. Who are the stakeholders and who do we need to involve and who do we need to communicate very early on? That's definitely important. And sometimes if you're just starting off, you don't necessarily know who those people are and who should be involved. And we find that, having some expertise from the likes of Quality Test and Vericode, we can give you some advice around who you should be looking to engage with and actually help you to go through that process as well. So yeah, I thought that was worth mentioning.
100%.
Brilliant, thank you. Okay, I've got a technical question here. Why would you use IAST over RASP? What are the advantages of IAST? So who would like that one?
Tom, why don't you handle that one?
Yeah, I can take that one. So yeah, RASP, which is runtime testing, basically, that's something that works generally in production. So if you looking to protect your applications, a bit like if you think of the more of a legacy solution of web application firewall, right? It sits in front of the application, production traffic will pass through it, and it will block anything that it sees as being malicious. RASP is similar, but it's augments the application with an agent, so it's a little bit more accurate in the way that it works. Now, IAST is much more of a developer-focused tool, so the idea is that the developer would use it very early on in the development cycle when they're doing, writing the code, when they're testing the code, to identify issues before it even goes into production or into runtime effectively. So, but RASP is much more of a, I suppose you could think of it as a security tool, really. It's there, it's blocking, it's protecting, but IAST is more proactive. So, yeah, those are the key differences. And I think IAST will really save time in a way that it will identify those issues, give the developers time to fix them, and prevent them from even going into a production application.
I think that was pretty comprehensive.
Okay, there's another one that's just come through, a training question. What type of training do you find to be most effective in enabling developers?
Tom, you want to start us off?
Yeah, I'll start with that one. I don't. It's a bit like the silver bullet, right? It's a bit of a myth, really. There's no single type of training that will be good for everyone. I think you need to have a few different options around your training, and because some people are much more engaged with like listening, watching. Some are much more hands-on focused. It also depends on the role. Developers typically quite enjoy the hands-on side, not necessarily the practical side. Whereas someone that's maybe more in a higher level role, the hands-on stuff's a bit too technical, and they want something a little bit easier to digest. That's more of a sort of AppSec best practice type high-level course. So I think a mixture is definitely important, right? So you've got the ability to provide some sort of watching content, some maybe classroom-based content, and then also some hands-on labs that really get the technical people involved and engaged. Gamification is obviously another good area to drive engagement, trying to keep the content really relevant to the individuals and the teams. So aligning the right campaigns to the right people, keeping it on topic as well. So maybe in the industry there's been certain news or hacks that are focused on a particular area, then sort of creating aligning labs that relate to that. So it's like educational. Things like that are really good and really effective to drive that engagement.
Yeah, totally agree. I think another element to consider here just goes back to, in general, management styles. Everyone manages in a different way and also receives management in different ways, and being open to the person and hearing how they react is really, really important. Coming down too top heavy often can turn people away. When you come down shouting emails at everybody, telling people fill this in by then, fill that by then, can often actually slow down the process, because people start becoming defensive. Oh, it's such a waste of time. I don't really want to do this. They're always just shouting at me. So really just making sure that you build that environment where people are coming and buying in as instead of just being told, which is obviously a tough challenge in general, but it's often, of course, it's really important to keep in mind here as well. Sarah?
Okay, I can't see any other questions, so thank you everyone for the questions that came through. If anyone has any additional questions or comments about any of the discussion in today's webinar, please get in touch with the presenters. Their details are on screen right now, or reach out to me and I will make sure your question is answered. My contact details are included within an email which will follow once the webinar ends. I'd like to close by thanking our presenters for sharing their time and wealth of expertise today. Aaron and Tom, it's been an absolute pleasure. And again, sincere thanks to our partner, Vericode, for guest presenting today.
Thank you, Sarah. And thank you, Tom. This really was a pleasure. You really have such a depth of knowledge, and I appreciate you sharing that with our audience. But I know I also learned a lot from this process, working with you and preparing this webinar. And really, just thank you.
Yeah, thanks for having me along. I've really enjoyed it. And yeah, as Sarah mentioned, if there's any questions or anything that you want to bounce off us, feel free to reach out. Thanks, everyone.
Thanks, guys.
Thank you, and not forgetting an extended thanks to our audience for joining us, as you both said. So just a heads up, you can save your seat at one of our upcoming webinars by visiting our website qualitestgroup.com/insights/webinars. It leaves me now to say goodbye. So until next time, when we look forward to you joining us again, all the best and goodbye. Goodbye, everyone.
Thank you.
Bye, guys.